Now. Okay, now we have completed already 2 lessons from me. And this is your agriculture systems 3210 course and traditional technology in Sri Lankan agriculture. So you are learning something special here in this lecture series. This is our lesson 3, sustainable agro-ecosystem with integrated land management. So that is our topic today. And also, as I told you even at the beginning, and all these lecture lessons, I told you that you can contact me over these 2 mobile phones and emails, right? At the same time, I just invite you to go through whatever that you need for further studies. You can follow these links. And also, this is a very limited time for a lesson. And further information you can find from internet and get ready for a good standing on this, good understanding about this traditional technology in Sri Lanka. All right. We have completed 2 lessons. Lesson 1, we talked about traditional knowledge and also our agricultural history. And we have divided into 4, 1, 2, 3, and 4. So we are starting from traditional farming life to present modern agriculture. And also this evaluation we have discussed. Finally, we have ended up with the Green Revolution that has begun in 1960s. Because of some reasons, you know that the World War II has just completed its way forward, and there was a bit food shortage. And also at the same time, some people predict that at that time, there could have been a drought. It has happened in a lot of countries. And because of that, Green Revolution has been taken place. And finally, after about 30 years, we found that there are pros and cons on this Green Revolution. And it has led to have some issues in agriculture. Then all of a sudden, we started talking about climate change. And also, we talked about greenhouse gases from different sectors like energy sector, transport sector, then industry sector, and waste management sector, then agriculture sector, and also forestry sector. So that we analyzed this situation, and we found that there's a possibility of mitigating GHG strategies in the agriculture sector, because agriculture also contributes about 25% of the greenhouse gas emission. And also we talked about carbon net zero balance by reducing greenhouse gases and also promoting carbon sequestration. So that now we are fully equipped with the plan, but we don't know what will happen because that plan is extending to 2050. And also I shared a document, recent document on climate change and agriculture in Sri Lanka, in the context of Sri Lankan situation. So that I hope you have received this document. Or if it is not, please put it in the chat box, then I will share again. Okay. Then we started lesson 2. There we talked about agroecological zones of Sri Lanka, how the climate affects crop growth, and especially rainfall variation within these agroecological zones. We have divided into 49, depending upon rainfall, the ability of soil to retain moisture, and also some other factors like vegetation. So that I hope that you will be able to understand some kind of variations in agroecology in Sri Lanka. Then we talked about droughts and floods, how it affects the agricultural production. And also we have discussed how we could evade these kind of impacts from agricultural productivity. Then we talked about two things. One is rain-fed upland farming, especially in the dry zone. Then lowland farming and mine irrigation. So those are two examples with problems, and we talked about technological solutions. Then we talked about home garden. That's another kind of farming system. We have, because we are in agricultural systems, we talked about rain-fed farming, then irrigated farming, and home gardens. So that is the end of lesson 2. And now today we are going to discuss about integrated land management, then land degradation in Sri Lanka, how it looks like, what it means. Then we will try to learn about ecosystems and agro-ecosystems. Then we try to go into depth of this ecosystem functions and services. Then agro-ecosystem and biodiversity. And also, because of this climate change, we wanted to introduce some concepts. Two concepts I am discussing here, as I already talked about evergreen agroecosystem concept. We are going to discuss again in detail, and the food forest gardens concept. So with these two concepts, we try our best to achieve carbon net zero, in addition to whatever we have discussed last time as strategies. So now we are equipped with the plan, roadmap up to 2050, then and the strategic plan. So it is up to the government now to implement this plan, and we hope that we can achieve these targets, even not in 2050, earlier than 2050. We plan in 2038, we will be able to have the carbon net zero balance. So today, shall we start now the lesson 3? Explaining integrated land management. You have heard of this integration: integrated pest management, integrated nutrients management, integrated water management. In one case, integrated water resources management, especially in this minor tank system. We know that they are using different water sources. One is rainfall. The other one is tank irrigation. Then third one is how we can have this groundwater influence to the paddy tract. So that they have to integrate. If there is plenty of groundwater, if it comes as a groundwater table within the first 50 centimeter, then no need to have any kind of irrigation. Then if we have rainfalls, no need to have tank irrigation. During drought period, we are using tank water and they can do both cultivation, Yala season and Maha season. So that is what we say about this integration. Now, integrated land management also have different components, and we will try our best to integrate them to keep all components safe and sustainable without damaging one from the other. So we say integrated land management is a strategic planned approach to the way we use land and natural resources. This approach aims to balance values of these land resources, benefits from land resources, risk and trade-offs, how we can exchange the benefits, share the benefits when planning and managing resource extraction. You know that our resources are very limited and we'll have to manage it properly to make an efficient resource utilization system. Then land use activities and environmental conservation and management. If you look at this picture, you can see that there are a lot of components interacting each other. You know that human population is there, and they are the people who are using this. In addition, there's a forest area, wildlife area, then water and fishery, agriculture, livestock, and housing and settlements. So that there are a lot of components we should be able to integrate. Integrate without having any kind of damage to any resource, but to have a balance. Now, this integrated land management approach, especially if you have a system, agriculture system, you have to prioritize in some places whether we get any kind of erosion, degradation of soil quality, biodiversity loss, we will discuss later. Then eventual loss of productivity occurs in these lands, especially when you take one ecosystem, the periphery of the ecosystem is influenced and affected by external factors. So that those are the vulnerable areas. Sustainable management strategies in these dry areas are needed for protection, preservation, and reclamation or rehabilitation. This is a fragile system, unstable system. So what we are trying is to have a sustainable system. Especially natural resources should not be damaged or should not be utilized and to be ended within our lifetime. Development of integrated approaches is critical to minimizing land degradation. So we talk about land degradation, especially because of the land degradation, agriculture is always affected. And the related societal and economic impacts. There's a need to promote actions for building and strengthening existing institutional capacities for regional, national, and basin level agencies to effectively address and integrate cross-sectoral aspects. So government should have a good plan based on their policies. Regional requirement is there with the responsibility. And finally, farmers are the persons who should get the responsibility at field level. So that all these should function together and we can achieve integrated land management targets. So when you say integrated land management approach, definitely it has a technical dimension, then human factors, then economic dimension, and also natural resource dimension. We will talk why we wanted to have these four dimensions together to achieve integrated land management. Technical dimensions. We have renewable natural resource, water, soil, vegetation, etc. We have to consider this when we are going to develop integrated land management programs. At the same time, how to manage land degradation, we have to come up with some innovative solutions. That has to be identified by us. Then mainly we have two. One is highlands and the other is lowlands. We are practicing farming in both these sectors. So there can be a potential conflicts and synergies between highlands and lowlands. For example, now even labor, how we can share family labor when we are practicing both together, especially because of this seasonal dimension of agriculture. We have seasons, Maha season and Yala season. When we start Maha season, we have to attend all practices in highlands as well as lowlands. So how we can share our time and also labor, family labor. At different levels, we should consider this one, these kind of conflicts between these two setups, especially not the home garden. Home garden can be done anytime with small labor force. But these two we have to consider. Then trans-ecosystem characteristics, ecozone characteristics of resources, we'll have to consider especially water. Now, you know that in Sri Lanka, I don't know whether I have discussed that, we have about 130 billion cubic meters annually we receive, but unfortunately, we are losing more than 50% of them to the sea. And also at the same time, you will experience drought in one portion of the island and flood in the other part of the island because of this water resource utilization pattern. For example, in the dry river basins like Nanoe, Daturoe, Kalawe, Yangwe, etc., Mallatwe, these rivers will yield less than 20% to the sea annually, keeping more than 80% within the terrestrial lands. Then rivers like Kalu, Gin, Nilwala, they are losing more than 80% of the rains received by the area of this drainage basin, and it will lead to get flood in the downstream. So there are problems of water management. We have not yet solved this fully. Then human dimensions of integrated land management approach. One is land ownership, land tenure. Because of that, sometime if you don't have this, farmers don't have this ownership, correct ownership. Sometimes there are a lot of encroached lands. We cannot introduce any kind of conservation measures because of the illegal status of this land ownership. Then resource management approach, we have to find impacts on livelihood of local people. That we have to consider when you are going to plan integrated land management. Then we have past experience, past knowledge, ancient people's knowledge. We call indigenous practices. On natural resources, there is an effect of indigenous practices because they have preserved, conserved, and ensured sustainability of these natural resources. So there can be a positive and negative. We'll have to consider both in planning. Whenever applicable, indirect social benefits of integrated management should be explicitly considered. Then mechanisms of conflict resolution during the implementation of management approaches should be built into the programs. So just imagine that we have a project, development project, aiming to achieve integrated land management so that we have to take these human dimensions into consideration. Economic dimensions, because people need money. So we'll have to evaluate what are the cost and benefits we are getting from integrated land management approach. Maybe social, environmental, and economic. Cost and benefit. How we can ensure long-term sustainability. And also, this integrated approach should be viable enough to practice continuously. Then capital investment into developing new infrastructure as well as maintaining existing ones, and traditional practices should be made there in planning. Linkages to national economic development should be elaborated because we have national policy, national economic development strategies. So that should be in par with our plan. So that is the economic part of this integrated land management. Then last part is natural resources, especially soil, water, then atmospheric effect, climate, all these. So we have to make a good balance from these natural resource dimensions. We cannot overutilize. We cannot make a damage on this system. We have to have a good process for this, and we'll have to give highest priority in integrated land management. Especially, we have to rehabilitate and restore ecosystems and in these marginal lands. Now the problem has come to the top of these issues like ecosystem degradation, not only land degradation. Especially that is the end of our lot of enriched biodiversity in this ecosystem. So we have to go for in situ conservation of biodiversity. We will talk about biodiversity later. Within the ecosystems, we'll have to consider. So these dimensions are closely interlinked and interacted with each other and need to be considered explicitly to develop fully integrated approach of land resource. What is land resource? We have land resource. We know that we have 6.44 million hectares. And rest of that 6.54 million hectares of all total, then about 0.1 million hectares they are allocated for water resources. The landman ratio is low, which is only 0.37 hectares per person. This is the whole land, right? If you say 6.54 available land areas. But when you take only croplands, only about 2.5 million hectares, nearly 39% is available for further settlements and agricultural production. So what we have to talk is that landman ratio in relation to croplands. So the per capita extent of cropland is as small as 0.14. So it is not 0.37. Utilized land for agriculture, if you consider, it's about 0.14 hectares per person. The major land use sectors in the country are agriculture. You know, agriculture is not only crop, but also wild livestock. So paddy, tea, rubber, coconut, and other perennials, non-perennial crops, and also livestock. And forest, close canopy and sparse canopy forest, then home gardens. All these will have to consider as land use sectors in agriculture. If you look at this diagram, you can see that how we are using this land resource. If you look at here, natural forest plantations, fast forest, close canopy forest, all these together will contribute to the total land by about more than 30%. And if you look at other land uses, 21.5, home gardens, 14.8. Then coconut, 6%, other perennials, 11%, and paddy, 8.8%. So those are existing land use pattern we have, and the sharing of these important land resource into these different agricultural sectors. How do we know land degradation is taking place? There are many evidences to show that the land degradation, that's a process, is taking place in any area. One is we can observe soil losses, very high soil losses. If you just go to a stream, you will find the color has been changed from watercolor blue to the cream color because of the mud. And also for reservoirs, we get very high sediment yields. And also soil fertility decline due to erosion, and it leads to reduce the crop yields. Then after some time, the land become marginal. Because of that, sometimes agricultural productivity will go down and people are reluctant to do agriculture because of this low fertile compacted soil. And also land degradation is not only soil erosion and this productivity decline in this agricultural land, but also salinization because of poor drainage, especially. Then in some cases, landslides and deforestation. So you will find some pictures here, soil erosion, then sometime the tank sedimentation here, then agricultural land, productivity decline, and also landslides and forest removal. So these are the manifestation, and these are the things that will indicate, show us that there is a land degradation taking place in our area. One important slide here, how we can say land degradation. To prevent land degradation, we are going to have a sustainable land management approach. That is what we need. So land degradation is the depletion of its not only physical, chemical, and biological productivity. Because if you do something like application of chemicals, your biological productivity will decline because it will destroy the whole microorganisms. So that it is not only physical, depletion of its physical, chemical, and biological productivity. To maintain the long-term productivity of land, we have to follow, or we have to adapt sustainable land management practices. When you say sustainable land management, it means use of the land to meet human needs while ensuring long-term production potential of that particular land and maintaining ecological functions. If we have a good resource, a land resource with favorable environment, then you will come up with a good ecology. Here the land includes not only land, not only soil, water, flora, and fauna. So that it is an ecosystem. When you say, I will come to that point later, when we are talking about ecosystem. We have the whole communities, living organisms, and it will go as ecosystems when we have biotic and abiotic, all kind of organisms and materials together. So we will call ecosystem. So because of the interactive effect of these resources and also energy flux, energy flow, one from one to the other. So that means land degradation is long-term depletion of the production potential and function of the ecosystem. Now you can understand how we come to this land management and at the end, ecosystem. So sustainable land management is maintenance of production potential and functions of the ecosystem. So that what we are really interested, how to ensure the sustainability of the ecosystem. When we ensure that, that means we have done sustainable land management. I will go to some principles. You must have heard of these, but anyway, you can recall your memory again. This how the life is organized. One is individual, that is organisms. Then if you have more than one organisms, we call populations, like this. If we have different populations, we can say that is like this, communities. Then communities, this biological part and non-biological part is there in that system, then we call ecosystem. So there are some interactive processes there. So there are ecosystems. Finally, At global scale, we have biospheres like this. That you have to understand clearly. If you have any problem, please ask from me. Sometime you can put it in the chat box. I will answer that. Okay. Further, you can understand here, this is individual. Then population. The same individuals will form a population. Then there are different populations will live together in a system we call community. So this community will contribute to a system with energy flux and cycling of nutrients, and also under the abiotic conditions, abiotic factors. Finally, it will go as biosphere because of the so many ecosystems. Even if you take a rural village, it has various ecosystems, right? To explain more, now this is a picture which is having forest here, farmlands, home gardens, and terrace lands here, like that. So many species. This is the individual one tree. Okay. If you have more than one plant, we call population. Here that is population. If you have two or more different populations, then we call community. Please remember this terminology. If you have these communities with other physical parameters and interactive effects or processes, we have ecosystems, right? So you have to separate the meanings of ecosystem, community, population, and individual. Okay. Now we have ecosystems, and also we have socioeconomic systems. People are there, the environment is there, right? There are interactions. So people get a lot of benefits through ecosystem services. I will explain what are these services. Then we will get benefits and values from ecosystems. Because we are getting the benefit, we are trying to manage it as a social response. We manage it so that we have good biodiversity and ecosystem condition, so that we will get ecosystem functions and services. Those will contribute to the benefit of people. So these interactions also, it is important and we'll have to understand. Okay. That is the connectivity, interaction, and complexity of ecosystem. If you have natural ecosystems without any socioeconomic systems, it will be there, right? Without management, without destroying, without utilization. But here, people are there to utilize, manage, and sometimes destroy. This is a tank bed area. It's a photograph. How do you see that with your knowledge now you gain? What is here? Okay. Now you have individuals here, individual, and it will form a population, right? This population has genetic diversity. Now this is white, black, brown. And there are interactions. Here you can see bird and these cattle, they have coexistence. benefiting each other. So this is the system. This is the natural system. When we understand the importance of ecosystems, how we can preserve them, how we can conserve them. One is that we should have a good knowledge based on all these ecosystems. We have to investigate, we have to make others aware, we have to give some training, especially for school children. Then we'll have to keep the knowledge. That is one. How we can take care of the ecosystem. That is one. Then people will not destroy this one. Second one, participation in ecosystem activities, just to feel it. People have to participate in different programs. This is one of the programs that we had, I think, 5-6 years ago, from students from Rajarata University, Environmental Management Department. We have organized one Samadana in Nuvaravava area after Posundi. So we could be able to have a dump of lot of waste materials, and students were so interested to collect them. And there are places where you get waste management to be collected from urban council. People are just dumping them. And also this is the program for planting program. And also here, the urban council people, they wanted to collect all these the materials, waste materials, thrown by these people. So here participation, we have to have a collective efforts. And also we have to think about how we behave, keeping in mind that the ecosystem should be conserved. Then participatory ecosystem management programs we have to launch like this. Okay. Third one, how you can manage ecosystems, because we are using services of the ecosystem, how we can manage ecosystems. We have to plan it properly, and we have to implement the programs, and we have to keep everything well maintained. Otherwise, it will be degraded after some time. Can you see these pictures? One is here. Is that an ecosystem or not? Can somebody answer? Is that an ecosystem or not? It's rice field. Is that an ecosystem?
Yes, sir.
Sorry?
It's an ecosystem.
It's an ecosystem because it has a lot of species in addition to paddy. At the same time, it has natural resources like water and soil. It has interactive effects of microorganisms, so that we can say that it's an ecosystem, right? So paddy field, so many people think that paddy field is monocropping, so there's no ecosystem, but it is. It's an ecosystem. Then home gardens, yes. Then this forest area, just backyard, ecosystem, right? And here croplands, this is chili, croplands, ecosystem. You can see all these, whatever we have learned. Then this is a natural one, so it's an ecosystem. So there are natural ecosystems and man-made ecosystems, right? In Sri Lanka, there are major ecosystems we could be able to identify. One is here, forest and related ecosystems, tropical forest types, riverine dry forest, grasslands, etc. Now you are learning, you are studying here in Anuradhapura. That's a dry zone. What is the forest type? Now you are in third year or fourth year?
Third year.
Third year. Okay, third year. So that you must have had an understanding about forest, right? It's a system of a natural asset. What is the forest type we are getting from dry soil? Can somebody tell me? I can read your names. Okay. Dry zone forest. What is the type when we are going to classify it? That's a dry forest, right? And also when you go to forest, you will see that it's a mixed forest. And also you don't see any kind of leaf fall in season in this forest area. That's evergreen. So we call dry mixed evergreen forest. Okay. Remember that the terminology dry mixed evergreen forest. And also we have riverine forest, grasslands, in addition to these forest types. Okay. Then wetland ecosystem. So many people just neglected. They think that it is not important. This is marshy land or flood plains. When you go to, you can observe one flood plain. When you visit Somavati, on the way you can find a flood plain. Then swamps, that is marshy lands. Then reservoirs. Then natural lakes, wet willows. So many. So these are also ecosystems. These are wet ecosystems. Then there are coastal and marine ecosystems. If you go to Batikalo, you will come up with some kind of pictures, photographs with mangroves. So coastal and marine ecosystems are there. Some people are reluctant to develop these ecosystems to freshwater ecosystems because we are losing a lot of important components from these coastal and marine ecosystems. Now, for example, in Jaffna area, we have now developed anyway uh, barrage. That's a valve door at the end of the land. Then you will find this water flowing into sea. If there is a shortage of water here, the brackish water will come up from the sea. So always we don't have a good fresh water in Jaffna area and also no rivers. So that even this elephant pass, now we are constructing this barrage to allow all these excess water from the terrestrial lands to the sea, but not allowed any brackish water from the sea. So what will happen after some time? After some time, say about 10-15 years, all these lagoons, brackish water lagoons, will become freshwater lagoons, so that there are enough water for Jaffna. Otherwise, we will have to divert rivers to Jaffna area. That is very difficult because our people are there in Jaffna area, so that we'll have to help them. Then the other well-known one is agricultural ecosystems. Agricultural ecosystems, we have paddy lands, we have plantations, we have fruit cultivations, then small crop holdings, other field crops, vegetables, export-oriented crop plantations, home gardens, and also still China farming areas are also available in these zones. So these are agricultural ecosystems. If you look at this as an example, this is an agricultural ecosystem. Okay. We have ecosystems. We know that when you integrated agriculture into that system, we call agro-ecosystem. So the definition is spatially and functionally coherent unit of agricultural activity, which includes the living and non-living components involved in that unit as well as their interactions. So agriculture ecosystem is where we are doing agriculture, and also we are managing resources like soil and water, and even especially microorganisms, soil microorganisms, without having any kind of degradation. That we have to do because we are agricultural scientists. I hope in future you are agricultural scientists, so you have the responsibility and right to keep all these agro-ecosystems without deterioration. That is what we need. That is why we are learning. That is why I am teaching. Okay. What is the difference between? Sorry.
I have a question.
Tell me the name first.
Hana.
Hana. Where is Hana? Yes, right. MSR Hana. Okay.
Yeah.
Go ahead, please.
Degraded lands. Can
Oh.
I ask in Sinhala?
It's okay, no problem. Go ahead.
Overuse of chemicals ඒ වගේ දේවල් නිසා දැන් degrade වෙලා තියෙන land එක agro ecosystem එකට include වෙන්නේ නැද්ද sir?
අපි කියන්නේ degraded ecosystem කියලා. We have ecosystems, but we don't have perfect ecosystems, right? If you look at these lands, degraded due to chemical fertilizer, right? Pesticides, overuse of something like even resources, water, or this non-adequate drainage we are providing. Lot of reasons it will be degraded. It will be degraded physically, chemically, and biologically, right? So whatever the level that we are having in a particular system, we still call it's an agro-ecosystem. But it is deteriorated. What we have to do, conserve it, develop it, restore it to become a good ecosystem, agro-ecosystem with enriched biodiversity. Hana තේරුණාද?
Oh sir, thank you sir.
Okay. Any other questions? You can use any language, not any language. Sinhala or English. Yes. Please use this time, otherwise you will lose your knowledge. Madhuka, Takshila, Vatsala, Miss Senaviratna. I don't know your name there, only Senaviratna. Then Bhagya, okay. Any question? So you understood everything, right? Very clear. Okay. Oh, you don't even a word you understood. Then you don't have any question, right? So I assume that you have already understood everything what I say, right? Now we are here. Agro-ecosystems and natural ecosystems, right? Generally, agro-ecosystems are having lot of interactive effects from human being. Because of that, there are differences. Productivity is agro-ecosystem is high because we are giving lot of inputs. But in natural ecosystem, it is low because it doesn't get any external support. Species diversity is low because we are considering one or two crops and also the weeds. But natural ecosystems, it is high. Genetic diversity within species, low because we are going to introduce one improved variety. But here we have high. Plant life cycles present, very few, because we are intervening in their life cycle, right? Natural ecosystem, we are not going to harvest anything from there. So it's more perennial and life cycle is complete always. But you know that we are going to collect some fruits from the natural forest, but we are not going to damage it, okay? Competition. What is competition? What is competition?
රිසෝස් වලට
තියෙන
කම්පීට් කරන
competition.
එක.
Oh,
ලිමිට්
what are the resources?
food,
Sorry,
land areas,
land,
space, water,
resource,
food,
water resource.
water,
Yes,
space.
yes. So there are resources everyone needs. Everyone needs, right? So you have plants with different depths of roots, different heights, different canopies, right? If you have one tree species everywhere without any other species, it has a specific root length, right? Root in depth. It has specific height. It has specific kind of canopy compared to the other. So that very high competition. That is why we say that if you are talking about agricultural systems, you have to introduce too many crops. Too many crops supported by some other trees. In natural ecosystems, they have different mix uh, species with different root systems, different height, different canopies, so that their competition can be tolerated. It is tolerable. Flowering, plant maturing, we are trying to synchronize them, but here naturally it is seasonal. Nutrient cycle. We are providing nutrients, we are taking nutrients out. But in the forest, It is closed. Closed system. Permanence. It is short. This is long. Human control. Very high here. Very low here. Ecological maturity. Except sometime matured home gardens, we call sometime it achieved climax vegetation. Otherwise, all these croplands are early and immature. But in forest lands, we have climax vegetation. Okay?
Sir, what is permanence mean?
What is permanence? Right? Yes.
Yes.
Permanence is that the vegetation is there. Right? And animals and organisms living in and the external no any kind of support so that it will become a sustainable system there. It's a long permanence. It's not that much permanence because we are always doing something, providing something, getting the house. So it is short. Permanence means how long it can be in existence. Okay?
Okay, sir. Thank you.
Right. Why others are not talking? Otherwise, you will feel sleepy.
Excuse me, sir.
Okay.
Sir, can you explain competition again?
Sorry.
Competition?
Competition. Okay.
Yep.
Previous. This one, competition.
Yes, sir.
Okay. Competition means any, now, in our human society, we have a competition. Why? Why we have a competition? Because we want to survive. We need food. We need water. We need money. For everything, we have a competition with the other people, right? Like that, we have tree species. It's a community. It's an ecosystem, but it's a community. This community also has in the competition between individuals. So they are trying to grab water, they are trying to grab food, they are trying to grab sunlight, right? Because of that, there is a competition. When you have a very large canopy trees, can you observe that small canopy species are not growing there? Because it doesn't get any kind of sunlight. Okay. Now, if you have a dense plant community, if you just introduce one plant there, if that plant does not get the access to water, does not get the access to nutrients and sunlight, it will not grow. Right? So for any system, this competition is there. You can easily understand that just observe the society. Even now, among these students, you have the competition. Don't you think? තේරුණාද ඒක?
Oh, sir.
Right.
Okay.
Any other? The other challenge we have is nutrients. In a system, generally, nutrient cycling is there. Now, for example, if you have a crop gets nutrients from the soil, okay, and it grows. whenever it ends up with the death, it will come down, it will fall down, and it will decompose. It will add nutrients to the soil. So it's a cycle. Now we will see how this nutrient cycling is taking place in agro-ecosystem and natural ecosystem. Just try to think about this one. One is then agro-ecosystem is we are cultivating something, right? We are cultivating, using the soil as a pool of nutrients. So we are keeping that soil with a lot of nutrients, otherwise we will add nutrients there. So our inputs are fertilizers and crop residues and sometimes atmosphere. You get, what are the things that you get from atmosphere?
Carbon.
Yes.
Nitrogen also.
Nitrogen also for a certain extent, yes. And also sunlight.
Yeah.
Then outputs. What are the outputs that we are getting from agro-ecosystem? Crops. Then removal from area. So we are removing crops. That means along with that, we are removing nutrients. Okay. Then erosion. If the land is eroded, the eroded materials will take even nutrients away. Leaching. So whatever that available in the soil, if it leaches, then it is not available to the soil. So those are the way that nutrients is removed. This is the way that nutrients is added. Okay. Then agro-ecosystems, you get runoff and nutrients will be lost. In natural ecosystem, inputs are plant residues within the system, animal waste, animal residues, then atmosphere as we discussed there, then nitrogen fixation, those are inputs in the process. Outputs, plants, animal grazing on plants, because animals need plants to consume as food. Then denitrification, runoff, and leaching. Any question on this? No question?
No, sir. Understood.
Okay. Agro-ecosystems, now we are talking about only agro-ecosystems. We are expecting few characteristics. The system should be productive. Otherwise, it will not provide us what we need. So it should be productive. And also it should be stable. Because now you use all these inputs and get the harvest. That is not the end. You have to have another season, cultivate and get the harvest. So it should be stable. Otherwise, it will gradually deteriorate to a point that you cannot, no longer you can use this as a productive land. So stability should be there. Productivity, stability, and sustainability. So you have to maintain the production level over the long run. Otherwise, you will end up with a very infertile land so that no one likes to do any kind of cultivation. Even your next generation is helpless to do any kind of cultivation on these degraded lands. So sustainability is the next one. Then equity. We are not considering much about equity. Equity means if there's a land resource, We have other resources today. Then we have facilities. We do everything in this land. And we are not sharing that one among all. That's not good. But when you look at this traditional system, sharing is a must. I don't know whether I have told you. They say sharing. They say bedagani. They say hadagani. And they say hada bedagani. You grow and share. And also bedahadegani. You share and grow. You share the lands in China and grow whatever you need. In your home gardens, you grow them. For example, if you need to share a jackfruit from the tree which does not belong to anybody, you pluck it and share. So that particular spirit we had in our traditional life, we don't have here. But that should be ensured here also. Share in agricultural production fairly. Independence. Agro-ecosystem self-sufficiency we have to ensure, because if we are trying to have always expectation from outside external resources, it will never become a good agro-ecosystem, right? For example, now if you just experience a disaster. Disaster means destroy everything unexpectedly. So that what you do, you ask for the help from outside. Grama Niladhari, then divisional secretary, so that they wanted to help you, giving some aids, giving some ration foods. So you are not independent, you are dependent. In traditional system, they have the independence. So this agro-ecosystem, to become self-sufficient, you have to minimize what is getting from outside. Okay, so you have to remember these special features of agro-ecosystems. One is productivity should be maintained. Then you have to ensure stability. You have to maintain sustainability. And also it's a bit difficult, but you have to share everything fairly, and it should be independent. So these are the special features of agro-ecosystem. We know that in our agro-ecosystems, we cannot expect all these. But anyway, we'll have to try our best, okay? You are familiar with this, and I think we have discussed about that, but this is agro-ecosystem. If you look at all these, we call agro-ecosystem, because when you say agro-ecosystems, you have plants, you have water, you have the atmosphere, you have the people, that is agro-ecosystem. Everything is there. And remember, this is tank-based agro-ecosystem. But when you look at separately, this is an agro-ecosystem, paddy fields. This is an agro-ecosystem with vegetables and fruit trees and timber trees. This is an agro-ecosystem, tank. Is it? I just want to ask the question, whether this tank bed area is an agro-ecosystem?
Yes, sir.
Yes, how?
Growing fish can be
Yes, yes,
harvesting fish.
yes. So we are doing fishery there, right? And also at the same time, we are collecting a lot of aquatic weeds in this system to utilize in our daily diets. And also for cultural activities, we are collecting flowers, especially lotus flowers, so that there are a lot of interactive things with other agro-ecosystems. And remember, tank is also an agro-ecosystem. Okay? Agro-ecosystem covers a wide range of processes and scales. Agro-ecosystems, one is at global scale. It contributes to carbon sequestration. Carbon sequestration is a process. Here, carbon dioxide is absorbed by the tree and put it in the soil as soil carbon. Okay, that is called carbon sequestration. Then at global scale, if you don't have a good kind of ecosystems, then you don't have this process here. At the same time, because of your activities, you are emitting greenhouse gases. So global warming is taking place. Then landscape scale, water purification is happening there. And erosion prevention is done at landscape scale, because landscape we are managing with a good plan, maybe drainage network, irrigation network, then land use patterns, everything is there, landscape scale. So that water will be purified, it will become crystal clear water. Even we can drink. You know that in up to 1960s, people use for drinking purposes tank water. But now you can't do it because it is polluted with chemicals. Then community scale. In the agro-ecosystem, we need crop pollination. It's happening because we are encouraging these kind of butterflies and bees to have here in the field, so that crop pollination will take place. Then pest control, community scale, we do pest control. Then field, plot, or individual person scale, we are managing local nutrient levels, disease and pest prevention in agro-ecosystems. Okay? Okay, what is ecosystem? As you understand, ecosystem, a community of organisms and its local non-living environment in which matter, chemical elements, cycles, and energy flows. So this is the correct definition for that, because it includes living and non-living things. Living means plants, animals, microorganisms. Non-living means soil, water, like that. So it's an interactive process here in the ecosystem, right? And also there are some cycles. You must have learned about cycles, right? Have you learned sulfur cycle, water cycle,
Yeah.
phosphorus cycle, carbon cycle, nitrogen cycle? Yes. So those cycles, I think you have already learned, because this is the third year. And please recall your memory. Try to understand this ecosystem is having a very strong arm for nutrients recycling and also resource recycling, and finally energy flows. Energy from one to the other, it transmits. For example, now when you have plant parts, it will decompose and it will add nutrients to the uh, soil, and soil will provide nutrients to the plant. So that for this particular action or activity, you need energy. Naturally, it provides energy to do that. That is the energy flows. Even from plant to, from plant to birds, pest to birds. There's an energy flow. When somebody consumes something, it's the energy flow, right? Life sustained by interactions of many different organisms functioning together and interacting through the physical and chemical environment. Okay? So this is a very complicated situation, and ecosystem is taking care of a lot of things, including our needs. Okay? That we'll have to learn today. Basic characteristics of ecosystems: structure, living and non-living, right? Processes, cycling of chemical elements, flow of energy. That's what we have discussed already. There are changes with time. For example, now if you cultivate the China land, after some time you abandon the China land and allow it for regeneration. So that land is rejuvenated to become fertile land after some time. That's called fallowing. Okay. So when you see the fallow lands, if you don't disturb that and cultivate, it will naturally change the vegetation, especially first weeds, then some other species, then some other species like. Finally, it will become a forest. Okay, that evolution is taking place. That vegetation succession is taking place in ecosystems. If you see that this succession is not taking place, evolution is not taking place, that is the end of that particular system. Then you cannot call it's an ecosystem. Okay. Okay. Now we have to think about why we are talking about ecosystems. If you don't have ecosystems, you don't get any service. So what are the services? One is supporting service. Supporting service means to support the system by itself, by having habitats, by increasing biodiversity, the process of photosynthesis, and very slowly, but it is there, soil formation. Right? So that will help the system be there forever. If you don't have those things, you will never expect an ecosystem. Then provisioning. Provisioning means giving something. To whom? People. So people are getting, the system is providing food, clean water. Just imagine how fish, wood, pollination, cool temperature, microclimate, right? Then regulating, controlling. If you just imagine that tank water agro-ecosystem, you will realize why what I say that now. It is true for all these agro-ecosystems. Regulating. You conserve water there, controlling flooding, and you will purify water. Carbon sequestration. Clean, fresh air. right? Because of now carbon dioxide is absorbed by plants. If you have more plants, you will get more absorption, you will get more carbon sequestration. Then cultural, how much you can learn from these systems. And it can refresh you, recreate you. Then you will get aesthetic beauty. If you are living in a village with a small tank, you go to that village, right? See the tank, now it goes dry and waiting for water, right? But still you can find some flowers in the tank bed. Dry tank bed is having some flowers surrounding area, and that is the aesthetic beauty that you are having. Then the other one is stewardship, leadership, support, everything you can find, because this traditional, that is why we are learning about this traditional knowledge. In traditional system, they have a lot of cultural activities. It will strengthen the unity of the people. It will facilitate the teamwork. It will protect the whole community. That is why they wanted to have this culture. And also they believe that sometimes their rituals will support their agriculture. Okay? In brief, you have again ecosystem services. Supporting means supporting services to the system itself. The others for human beings, food, fresh water, wood and fiber, fuel provisioning. And regulating means climate regulation, flood regulation, disease regulation, water purification, everything. Cultural means aesthetic beauty, spiritual aspects, educational purposes, recreational purposes. Now, these school children can go to these ecosystems and learn a lot. I mean, even you can do. You can have a good understanding about that and write lot of things. You can find lot of things there. And on top of this, now we are encouraging ecotourism in these lands. Now we are using two terms. One is functions, one is services. Function means in that particular system, what is happening. Services means as a result of functions, how human will be benefited. That is the difference between functions and services. Usually functions are considered as the biological processes underpinning and maintaining the ecosystem, while ecosystem services are defined as the direct and indirect contribution of an ecosystem to human well-being. So I think you have understood the difference between functions and services. Although we say supporting services, it is supporting functions. Provisional service, regulating service, cultural service, okay? Why we need to protect our ecosystem? One is supporting service, as we told, right? Why? It is helping to have nutrient cycling, soil formation, pollination. We can consider that as a seed bank, production of oxygen, and also absorption of carbon dioxide. And also it will provide the facilities for habitats for lot of people, lot of creatures. Regulatory service. It will purify the air. Now we are polluting the air. Then climate and water regulation, flood and erosion control, because this is an absorption point, so that it will discourage flood. And because of these measures, it will discourage the erosion. Water purification, waste treatment, detoxification, human disease control, biological control of agricultural and livestock, pest and disease, storm protection. These are the regulatory services. Okay. Provisioning processes. It will provide food, fruit, vegetables, wood, fuel, wood, fiber, biochemicals, natural medicines, genetic resources, ornamental resources, freshwater, minerals, sand, and other non-living resources. So many things are provided by the system to people, so that it is our duty to tell people how they are, how they should be interested to protect these ecosystems. Cultural. There's a cultural diversity, and they are doing spiritual and religious activities. You can increase your knowledge, educational and aesthetic values, social relations, sense of place, cultural heritage, recreation and ecotourism, communal, symbolic. So, a lot of cultural aspects we are expecting, but it does not have all these together in one place, but there are places where you get. Okay. Genetic resources. Genetic resources. We have plants growing to get a harvest. So we will get the produce. It's from maybe land race, cultivar, plant germplasm. You may not, I may not need to explain everything, right? What is land race? Can somebody tell?
Is it a wild variety?
Yes. Wild variety or local variety, okay, which has been grown for a long time, or which is in the wild, which are adaptable to the conditions prevalent in that particular region, in that particular area. So those are land races. We are collecting land races, right? Collecting land races for crop improvement studies. Cultivar means it's a variety, right? Plant germplasm means we are having genetic resource collected somewhere and keep for plant breeding, plant improvement, variety. Sources of plant germplasm we are collecting from jungle. Then we are collecting these land races and cultivars grown by our people. Then some cultivars are now not working properly. Advanced breeding lines and other products of plant breeding programs, current cultivars. So we have a lot of sources to make a crop and release the variety starting from plant genetic resources. So plant genetic resources can be found as land races, farmers' secrets, farmers' varieties, parental lines of hybrids, genetic stocks, primitive cultivars, wild and weedy relatives. Okay. In Sri Lanka, can you identify this? What is this plant? Okay, just see and try to understand what it means. About 7,500 plant species constitute the flora of Sri Lanka. Flowering plants constitute about 3,360 species, belong to 1,350 genera and 200 families. The flora contains by about 830 endemic species. The low country wet zone and mountainous areas in southwest harbor 90% of endemic species. Over 600 species have been used as medicinal plants. Especially in the dry zone, you can find a lot of medicinal plants. Number of cultivated food plants have their wild relatives. Especially if you talk about this jackfruit, breadfruit, citrus, you have wild varieties. The yams, mango, then pepper, rice, and pigeon pea. What is this plant?
Pigeon pea.
Pigeon pea, yes, because we have tried our best to popularize this pigeon pea. Now 2 times. The third time is there. Because of some other problems, we could not take it off. And this is a good plant for drought and dry soil. And only problem is this Maruca tetrulalis, the pest attack. Otherwise, it's a very good one. We can even replace all dal. Agro-ecosystem biodiversity. We should have these components. Pollinators, predators, herbivores, non-crop vegetation, earthworms, soil mesofauna, soil microfauna, all these in that agro-ecosystem biodiversity is supported by these components. It has a function. It has functions like population regulation, the biological controls, biomass expansion, nutrient recycling, then competition allelopathy, soil structure nutrient cycling, decomposition, predation, nutrient cycling, disease suppression. All these are functions which are benefited to the farmers. Then we can enhance by using a lot of practices like intercropping, crop rotations, no tillage, or minimum tillage, green manure, windbreaks, agroforestry, compost, and organic matter input. So that we have different strategies. One day we can come up with a concept using these strategies to strengthen the agro-ecosystem activities. Biodiversity is the variety of all life forms on Earth. The different plants, animals, and microorganisms. They are genes. And the terrestrial, marine, and freshwater ecosystems of which they are a part. All these systems. So diversity exists at different scales. Sometimes at regional scale, ecosystem scale, species scale, and genetic scale. Biodiversity is not static, but constantly changing. That we have to understand. It is increased by genetic change and evolutionary process and reduced by processes such as habitat degradation, population decline, and extinction. So there are species which are now endangered. There are species which are extinct at the moment, so that it will not come to us again. And there are some species which are sustainable because they can tolerate the changes. Biodiversity, 3 types. One means genetic diversity. So that means different DNAs, but you can see the same species. Species diversity means you can have different species. Ecosystem diversity means variety of habitats, ecosystems, communities in different places of the world. Wide range of terrestrial and freshwater ecosystems which carry a high biodiversity. If you are not disturbing, one of the global biodiversity hotspots in the Asia-Pacific region is Sri Lanka. The ecosystem diversity extends from forest ecosystems to coastal and marine ecosystems. Terrestrial ecosystems include tropical lowland rainforest, where 90% of the endemic woody plants and 75% of the endemic animals are found. That is why we say that we are having a biodiversity hotspot in Sri Lanka. So in terrestrial and freshwater ecosystems, freshwater crabs, amphibians, land snails show the highest tendency. Then conserved biodiversity would provide a wide range of ecosystem services. We are conserving a lot of, especially freshwater, then improve the climate, reducing soil erosion, regulating surface runoff, and providing bio resources. So if you do this one, you will conserve biodiversity in that particular area. Agrobiodiversity means, as we explained earlier, it is biodiversity, but with agriculture, like ecosystems with agriculture, agroecosystems. So we have to understand importance of biodiversity in agricultural ecosystems. In agriculture ecosystems, biodiversity is important because of it supports production of wood, fiber, fuel, fodder, etc. Then it will conserve the base, ecological base to sustain life for future. And also it allows adaptation to change in situation like climate change, natural disasters, etc. Because once after having natural disaster, sometime you will see that it is coming up. Even if you set fire to a land, again it will, this sprout, some plants will sprout. Climate change, it's coming up, and there are a lot of things we have to do. I have discussed some, but not all. But did you receive that document that I wanted to share? Climate change and agriculture in Sri Lankan context. Did you get that? Yes or no?
No, sir.
No.
No, sir.
So please ask Miss our teacher, Nishamani. And I have given to Miss Nishamani, and she will share it. Okay? It will update your knowledge on this climate and agriculture. It's a new one.
Sir,
Sir, oh yes.
can you please share this document with us?
I can do it. How?
Um, through Nishamani madam?
Yes, you mean the document, right?
Yeah, this one.
This one means this slides?
Right now, right, yeah, right now you sharing this presentation.
This now, have you received this all other presentations, 2 presentations early?
No, sir.
No, sir.
Okay, I will tell Ms. Nisamani to share this because I have sent already all these lessons. Today I am going to send this one also. At the same time, I have already shared that particular paper. So you will get it, and please discuss next time if you don't have that. Okay?
Okay, sir.
Even if you are interested, you can get the recording also, right? I want you to read and read again. I want to listen and listen again and try to understand. Okay. Then in agrobiodiversity, there are components, habitat diversity, there are different habitats, interspecies diversity. That means within that species, there are a lot of plant, animal, and microbial differences. You get species, intra-species diversity. Because of the one crop, we have different varieties so that we get whatever the quality that we need, including yield and nutrients within that, even medicinal values, harvested species used for food like wheat, rice, maize, etc. So those are the components of agrobiodiversity. So whenever you have agroecosystem, you see that whether it has all these components as far as the agrobiodiversity is concerned. Benefits, environmental benefits, economic benefits, social benefits. We have already discussed a lot of these benefits in agroecosystems. Sustainable development goals. So in this yellow color, you have a lot of goals which are related to this agricultural biodiversity. Please try to understand by reading this. If there is any problem, please tell me next time. I will discuss that. Why we need biodiversity sustainable? Because we should not lose the agricultural biodiversity in any landscape. Because it provides services, it regulates, and also there are cultural services. And top of all, we are providing habitats for a lot of predators and supporters. How we can ensure sustainability of agroecosystems? We have some problems. One is biodiversity loss from farms because they are trying to have monocropping. And also they use chemicals. And sometimes they are not worried about land degradation due to erosion. Then damaging chemicals, there are chemicals. And these chemicals, especially fertilizer, you will get nitrogen leaching, then greenhouse gas emission, and sometimes you will lose microbial populations because of chemicals. Restoring food nutrient density to improve our health. Because of different kinds of degradation, we have to restore. Otherwise, the agroecosystem will lose biodiversity at the same time productivity. Regenerative agriculture for a resilient, sustainable future. This regenerative agriculture is a new term. Because of this agroecosystems, we have to keep that soil organic carbon level, and we'll have to encourage microbial communities and functions, and we'll have to arrest accelerated soil erosion. So those are the aspects here under regenerative agriculture. So I have two concepts. One is evergreen agroecosystem I discussed earlier also. So there are vision, integration, and approach. Benefits are there. Please read them because I have discussed already. But if there's any problem in this evergreen agroecosystem, there's a new one we have introduced, especially to mitigate greenhouse gas emission and encourage carbon sequestration. evergreen agro-ecosystem, we have main features. There are crops with different duration, so that the cultivated land will not be under fallow. That is zero fallow period of the land. Now we know that paddy cultivation is taking place. There are fallow periods. Rain-fed cultivation is taking place. There are fallow periods. So we'll have to have using this evergreen agro-ecosystem concept to make the land always green. So green manure plants such as Caesidia, Adathoda, Erythrina, Thespecia can be grown as hedges without disturbing the crop area. Shade management is adapted to minimize light competition. So competition for light should be minimized. The live fence we can maintain. It has a lot of other trees which will add a lot of manure to the cropland. The farmer should have a field management self-evaluation schedule because he has to monitor the progress by himself. That will ensure the sustainability of the agro-ecosystem. This is the live fence recommended trees. A lot of trees are there. You can read, you can understand this, what it means. All these are legume trees and creepers. Creepers also, these are useful, these are beneficial. They can use for foods and fruits, so that, and also for medicines, so that it will make a good evergreen system. These are the creepers for the live fence, vegetables, and traditional crops like this. And here, live fencing, very beneficial. You can read this one. These are the pest repellent plant species we are recommending to the palm, sere. This is lemongrass. This is turmeric, ginger, aratta. Because of the smell that we are getting, pest will be repelled. That is the principle behind that. So this will be replaced by the application of pesticides. Then the next one is food forest garden concept. This is again, even in home gardens, we can practice different species for different purposes. Those are, because of this, we can have a good microclimate like what we had in Gangoda. Early people enjoyed that microclimate. Now we have to make it again in this wood forest garden. And there are a lot of characteristics. One is crops are diverse. The forest effect is there. Multi-layer architecture, canopies at different stratum, nutrient recycling, shade management, moisture sharing, microclimate, habitats, pest control, livestock integration, aesthetic. Now you can see all these things are benefits from wood forest garden, like what we read early from this traditional tank village system. So we are trying to manipulate that one to become a wood forest garden. Wood forest garden, we have different canopy layers. For different canopy layers, we have different species, even creepers. So here you can have the soil for potato, sweet potato, and carrot. Then just above that ground layer, you can have ground cover, Gutukulam Kunuan. Like that, you can select some species, whatever that farmer needs, and see that it's grown as a mixture of crops. Especially this is close by to the fence, live fence. So live fence and food forest garden can be combined together to make a good green cover, and it will help to minimize the effect of climate change. So our expectation is that we have people like this. Now I got this particular picture from maybe Tantrimal area. And what we need is to have this kind of multi-story home gardens, which will be multi-purpose and beneficial to the farmers. Now these people are getting a lot of things from outside, and they are poor people. They don't get a good profit from home gardens. So that is the aim that we have. I think you can read all these. If there's any question, you can ask in this next time. And if you need revision, we will do it